Before we begin, a quick disclaimer. This podcast is for educational purposes only and is not medical advice. Peptides, including cagrilitide, are still being researched. Always consult a qualified healthcare provider before beginning or changing any treatment, supplement, or peptide regimen. Cagrilitide is one of the newer peptides attracting attention in scientific and medical discussions. It is an amylin and calcitonin receptor agonist, and it is being investigated primarily for its potential role in weight management and metabolic health. To understand why researchers are so interested in it, we need to take a step back and look at what amylin is and why it matters. Amylin is a hormone that is released alongside insulin from the pancreas. Its role is to slow gastric emptying, suppress glucagon secretion, and regulate appetite. When combined with insulin, amylin helps keep blood sugar levels balanced after eating. Unfortunately, in people with type 2 diabetes or insulin resistance, amylin function is often impaired. That has led researchers to explore ways to mimic amylin's effects with medications and peptides. Cagrilitide stands out because it is designed as a long-acting amylin analog. In plain terms, that means it can potentially stay active in the body longer than natural amylin or some other synthetic versions. Longer activity may lead to more stable results with fewer doses. This is part of a new generation of peptides and small proteins being developed to help with metabolic conditions like obesity, diabetes, and related disorders. One of the interesting things about cagrilitide is how it works when combined with other peptides or drugs. Early studies suggest it may complement GLP-1 receptor agonists. GLP-1 drugs, like semaglutide or retatrutide, are already widely known for weight loss and blood sugar control. When you pair amylin activity with GLP-1 activity, the effects on appetite suppression, delayed gastric emptying, and overall satiety may be stronger than either alone. This synergy is what excites researchers and could make cagrilitide part of future combination therapies. Let's break down the main effects being studied. First, appetite regulation. Cagrilitide appears to help reduce food intake by signaling satiety in the brain. People feel fuller sooner and may naturally eat less. Second, gastric emptying. The stomach takes longer to move food into the intestines, which stabilizes blood sugar and prolongs satiety. Third, glucagon suppression. Glucagon normally raises blood sugar, and excessive levels can be problematic. By reducing glucagon, cagrilitide helps maintain more balanced glucose. Beyond weight and blood sugar, there is interest in cardiovascular outcomes. Since metabolic diseases are closely tied to heart health, anything that reduces weight and stabilizes glucose may also improve cardiovascular markers. While it is too early to draw conclusions, some studies suggest potential benefits for blood pressure and lipid levels as well. It is important to note that cagrilitide is still experimental. It is not widely available on the market, and it is undergoing clinical trials. Most of the data we have comes from controlled research settings, not from long-term real-world use. That means safety, optimal dosing, and long-term effects are still being clarified. Some reported side effects are similar to those seen with other metabolic peptides, such as nausea, vomiting, or gastrointestinal discomfort, especially in the early stages of use. So, how does cagrilitide compare to other metabolic peptides? If you look at GLP-1 receptor agonists like semaglutide, Those are already established and approved in many countries. They are powerful on their own, but they mainly target one pathway. Cagrilitide adds a second pathway through amylin and calcitonin receptors. Combining the two may be like hitting metabolic dysregulation from multiple angles at once. For people struggling with obesity or type 2 diabetes, that could mean better results. Another way to think about it is duration. Some GLP-1 agonists are weekly injections. Cagrilitide is being developed with extended half-life properties, meaning it may also allow for weekly dosing or even longer intervals. For patients, convenience is a big deal, and adherence is often better when injections are less frequent. As the science unfolds, researchers are looking not just at weight loss numbers, but at body composition, fat distribution, and preservation of lean mass. Losing weight is one thing, but maintaining muscle while reducing fat is the real goal for long-term metabolic health. If cagrilitide shows it can help tilt that balance, it will stand out even more. There are also questions about neurological effects. Since amylin and calcitonin receptors exist in the brain, there may be roles in regulating mood, cognition, or neurodegenerative pathways. Some early data suggests amylin analogs could even have protective effects against Alzheimer's disease, though this is very preliminary. Still, it adds another layer of potential interest. When we think about the bigger picture, cagrilitide fits into a trend where multi-pathway metabolic therapies are replacing single hormone approaches. First, we had insulin, then GLP-1 agonists. Now combinations of GLP-1, GIP, glucagon, and amylin analogs are being tested. The goal is comprehensive control of metabolism, appetite, and energy balance. In terms of patient populations, cagrilitide may be especially helpful for people who do not respond fully to GLP-1 drugs alone. Just as not every medication works for everyone, combining mechanisms gives more tools for individualized treatment. That could mean doctors tailoring peptide regimens based on genetics, metabolic profiles, and lifestyle factors. Now, let's talk briefly about the future. Pharmaceutical companies are running Phase 2 and Phase 3 clinical trials with cagrilitide. If results continue to be positive, it may move toward regulatory approval in the coming years. Until then, it remains a compound of research interest, not something you can simply purchase at a pharmacy. For those interested in peptides, this highlights an important distinction. Some peptides are widely available in research supply channels, while others, like cagrilitide, are locked behind ongoing trials. That doesn't diminish the excitement, but it does remind us that safety, oversight, and scientific validation are critical before widespread use. Let's circle back to the key takeaways. Cagrilitide is an investigational amylin and calcitonin receptor agonist. It shows promise for weight management, blood sugar stability, and potential cardiovascular benefits. It may work even better when combined with GLP-1 agonists, making it part of the next generation of metabolic therapies. Early data is encouraging, but it is still experimental, and more long-term research is needed. Before we close, another reminder. This discussion is for educational purposes only. Peptides like cagrilitide are still in clinical trials. They are not approved for general use. Do not attempt to obtain or use them without proper medical oversight. Always consult a licensed healthcare provider when making decisions about your health. Thanks for listening, keep learning, and stay curious.